Okay, so which tangent one do you want to see then? Or does it not matter? Well, I did the first one was EX, wasn't it? Yeah, so maybe I'll just do that one as revision then. So y equals EX, and what was the point?
0, 1.
0, 1. Okay, so first derivative equals EX, and then you put x is 0, so that's 1. So that's the m. So we have y equals mx plus c, y equals 1x plus c, and then we can put the point in to get the c. So 1 equals 0 plus c, so therefore c equals 1, and we have our answer, y equals x plus 1. Yes? Come on here. Wait. You left the door open. Come on. Right. So we'll do a normal one next. Which one? Okay. You'll have to read it out to me in a moment. Did you find your notebook? He took it, huh? Ah, okay, that's why. Yes. Okay, so just read it out to me. Hang on. What's the function for number 6?
Y equals
Yep.
5x squared minus 2x.
Yep. And I want the normal, yeah? X equals? Okay. Right, well our first thing to do is we have the x, so we should get the y. So minus 4 squared is 16 times 5 is 80. 80 plus 8 is 88 minus 8. So is y 80 here?
Yeah.
Great, okay. Now, the derivative will be 10x minus 2. And we have to put x as minus 4, so that'll be minus 40 minus 2. So minus 42? Yes? Okay. So we get m equals 1 over 42. Wait, hang on. There's too many people talking. So go ahead.
Y equals minus 80 or 80?
Where y is 80. Are you asking about the y over here?
Yeah, that's minus?
I got 80, not minus 80.
We got it from the early equation.
Yeah.
What is it equal to minus 1?
Because this time now is perpendicular. Remember perpendicular? You know this word?
Yeah, I know. How do you find 42?
Oh, which one? The minus 42? Ah, you put x as minus 4, see?
Minus 4 minus 2.
Yes. Oh, good, Amjad. You're improving on your mental arithmetic. Good job. You've been practicing over the weekend, I see, yeah. Right, so now that we have the m, we can find the c by using this point. So we get 80 equals minus 4 over 42 plus c. So c equals 80 plus 4 over 42, which, what's that going to be? 2 over 21 is as good as it gets. So what's that when you add them together?
0 minus 0.
No. Give it to me as a fraction. What is it?
1682
1682
over 21.
over 21. Great. So that's the answer now. You got your m and you got your c. So you have y equals 1 over 42x plus 1682 over 21.
But I got 80.
Where? For what?
1682 over 4 is 8.
You got 1682 over...
4.
I'll give it here. One 682 over 21. Show me where. But you know that's wrong. Because how could 80 plus 2 over 21 be 80? Right? Think about it. Don't be using decimals now.
But you did decimals.
Don't. This. But I told you this was wrong. Remember? Yes. All bad. All wrong. Well, no, not these ones. But I didn't ask them to do these ones. Yes, as a decimal, it's approximately 80. But we don't like decimals, okay? Alright, so I'll write that one down. We'll have a look at the last chapter actually now. Got that? Okay. Now, now there was no doubt whatsoever. That was definitely Arabic you were speaking, wasn't it? Wasn't it?
You need a cake.
Oh, there's no cake big enough, Andy. I'm sorry, I'm getting tired of this here in Arabic, so off you go. Yep. Hey, now you're just lucky I didn't hear you speaking as well, because you were going. Yeah, I didn't hear you, but you know, if I just pause for a few more seconds, I know that there was Arabic being formed here. You know, because I could start to hear. So, get going. All right. Now, you can come back for the second class. Go. Now, we're going to look at the last topic now. So, last topic. This chapter that we're just finishing up is all about derivative. So then the last chapter for semester 1 is antiderivative. Okay? So, as the name might suggest, antiderivative just means the reverse of the derivative. So for example, if I go from x squared to 2x, that's called the derivative. And going from 2x back to x squared would be called the antiderivative. Now, you might have spotted a problem here, because if I have x squared plus 1, what's the derivative here? 2x. But the antiderivative of 2x is x squared plus 1. You notice how it doesn't quite match up. And the reason for this is there's always going to be a constant at the end that you can't identify, because when you differentiate a constant, it vanishes. So this means, in general, in this particular case, the antiderivative would be x squared plus c. So this here is just a constant. Anyways, what are the symbols for that? So the way to represent antiderivative is like this. You put this symbol around what you want the antiderivative of. So by writing this in the front and this at the back, basically means you want the antiderivative of what's inside it. How can you check that it is actually the antiderivative? Well, the check is very easy. If it is the antiderivative,
2x.
yes, thank you. Sorry. Sorry. The 2 should be here. How can we check that it is the antiderivative? Well, if it is the antiderivative, then it must be the case that the derivative here takes me back to 2x. So what's the derivative of x squared? It is 2x. So I always like to think about it like this. X squared derivative is 2x, so that's like going down, and then antiderivative is like going up. So are there rules? There are, and they're very, very similar to the derivative rules. And in fact, we could work them out, okay? So, going down. So the first rule, what's the antiderivative of x power n? So the power, what happens to the power? Anyone know this one? No, it goes up because it's the opposite now. And then you divide by the new power, plus c. Now, let's check that this rule works. Let's check. So, this rule is only right if the derivative here gives me what? No? What should this give me? The original, the xn. Yep. So what do I do when I want the derivative? What's the normal derivative rule? Bring the power down, and then the power loses 1. So instead of n plus 1, it will now be n plus 1 minus 1, so just n. But these cancel, and you see I am left with the original. So anyways, I won't do this for each rule, but my point I'm making is you can very easily check that the rule works because the derivative of the rule should give you the original. So that's the first rule. If you want to number them, rule 1. So you increase the power by 1 and divide by the new power. Rule 2, if you have just the constant, it will be the constant times x plus c. Okay. Rule 3, cos x will be sine x. And then rule 4, which is similar, sine x will be minus cos x. Rule 5. Yep, exactly. Because after all, the prefix antiderivative, like the opposite. 5. Well, what about this one? Who thinks they know what this one will be? Tan. Because you know that the derivative of tan is 1 over cos squared. So the antiderivative of 1 over cos squared is tan. ENX. Now, what about this one? Any ideas? Could you try and work it out?
Same.
It's the same, except there's something in front. No, because remember it's anti, so it should be something kind of opposite. So 1 over n. So instead of multiplying by n, you divide by n. There is none for log for semester 1. And then last one now. I'll change it to 1 over a let's see, so we've got our xn, our e sine cos squared. Yeah, that's all of them.
With the roots.
Roots is just power half. So let's have a look at some examples then. So again, just like with our lesson on derivatives, it's really just a matter of referencing and using these rules from the formula book. So make sure you have all of these. They're very important. So what's the first one? I think I asked you for the antiderivative. So what's the first function? Question 1, part A. Yeah. 14x plus 1. Okay. So our first example, antiderivative 14x plus 1. So it's like there's a power 1 here. So you increase the power by 1 and divide by the new power. And then what happens to 1? It will become what? X. This is which rule number? The second rule, and how I numbered them. So the answer is 7x squared plus x plus c. Okay, write that one down. That's coming from there. It's like becomes 1x. It's the second rule. But c? See, I told you at the very beginning, it's a number we don't know, the constant.
You should probably write 7x squared instead of 14 over 2.
Oh, I just did. Yes. We have a look. What else is there here? They're all kind of the same, really. Okay, so not too difficult. Let's look at a more difficult one. You know what? I'll do one with a square root in it. Okay, so I don't know if it's in the book. Right. So here's 1 over square root x. So the first thing you need to do is change it into a power. So 1 over the square root of x is x to the power minus a half. And the rule says you increase the power by 1 and then divide by the new power plus c. Which will be equal to this. So you add 1 to the power and divide by the new power.
It's minus 1 over 2, right?
In the question, yeah. This is a minus here, yeah. But then when you go to here, you add 1 to the power and then you divide by the power.
And if it's positive?
It's the same. Mm-hmm. How else could this be more difficult? Let's see. Yeah, I suppose. What's G?
2g.
What's 2G? What's so difficult in 2G?
2 over e power 9x.
Ah, yes, that is a good one. 2G. 2 over e power 9x dx. That equals, firstly, 2 e to the minus 9x dx. Now, I should say something at this point, actually. It's good if you think of this here and this here a little like open bracket and close bracket. So this is like open bracket and this is like close bracket. And what I mean by that is that this 2 here can be taken out in the front. Just like you could take something out of a bracket. The only requirement is that you're only allowed to take numbers outside and not anything when x in it. And the reason x's don't go outside is because x's need to be anti-differentiated. So this plane 2 here on the numerator can be taken out in front, and it doesn't affect the answer. Okay? And then what I did here was I changed this from denominator to numerator, but with a minus power. And now you can look at your rule. So whatever rule number that is, this will become 2 bracket e to the minus 9x over minus 9 plus c. Now, also, this can be written as minus 2 over 9 e to the minus 9x plus c.
It's the 2 and not times the c.
Yes. Now, why not? So, you could write it as 2c if you want, but I didn't. So why not? Why was it okay for me not to write 2c? Why could I just write c? Any ideas?
Could be exponent.
Yeah, like the purpose of the c at the end is just to be a stand-in to represent any constant at the end. So writing it as 2c or 3c is not any more helpful. It's still just representing a constant at the end, and you don't know what it is. So it's like literally a blank space that says there is a number here, and I don't know what it is. So the 2c offers no extra help. Yep.
If you were to find c,
That is the next example I'm going to do. Yes. So then it would matter. Yes. So I'll just write that down, and then we'll do an example where we can find the c. Do you write this down, Amjad? So that's basically question 1 and 2. So in number 3, the only difference in number 3 is that we can now find the c. Talking and your phone is ringing at the same time. That is talented. Why would you got an alarm set for the middle of maths class? Oh, it must be to remind yourself to start talking, is it? Right, okay, next example now. So let's have a look here. 4x plus 3. No, 4x plus 3, yeah. Okay, so here, remember that little tick means it's the derivative, and I would like the original. So how can I go from a derivative back to the original? Antiderivative, yeah. So let's just do this in our head. So that would be 4x squared, yeah, power 2, over 2. It's this here, plus
c.
No.
X 3x.
3x. Yep, plus c. So this is 2x squared plus 3x plus c. But you can find the c in this question because, yes? What are you doing so late?
I don't know, I'm following another schedule and I've been going to other classes.
Come back at 2 o'clock.
In 2 o'clock?
At 2 o'clock, come back here. You understand?
Okay, thank you.
Alright, so in this one here, you can find the c because in the question I tell you something about fx. I think I say f of some number, what is it? F of 3 equals 29. So that means if I put x as 3, I should get 29 as the answer. So we can check. 2 times 3 squared plus 3 times 3 plus c must equal 29. So this is 18 plus 9. Yeah, 27, isn't it? plus c equals 29. Therefore, we must have c equals to 2. So we can fully find the original. It's 2x squared plus 3x plus 2. It's given in the question. Where's your book? Oh, where's your book? Yeah, well, you can still read it. Where is it?
No, just page that I showed you right there.
It's missing the last pages.
Yeah.
That's outrageous. Well, at least share. Here, this one here. Okay, so here we could find the C. So what I want you to note is that generally we cannot find the C unless some information extra is given. So in this case, the extra information that was given was you were told that when x is 3, the y should be 29. Now, there are two verbs here. So if you look at the top of the page, page 89, you see there's a word at the top called integration. So there's two verbs here. What I've been using so far, I've just said anti-differentiate, but there's another verb which is integrate. You see it up the top there, integration. So integrate is a verb that means anti-differentiate. Okay? There is a tiny difference between the meaning of each word. And until you go to university, there will be no difference between the two. So I will switch between the two words. Sometimes I'll say anti-differentiate, sometimes I'll say integrate. There'll be no difference right now at this level between the two words. Although becomes an important difference for, let's see, engineers will see it later, I guess. Biology students never. Okay, so this one is not too difficult once you follow the rules, and I've given you all the rules, so let's see how many you need to do. I feel like changing a little bit today. Okay, so from number 1, can you circle these? So in number 1, I'd like Andy be quiet. Please, Andy. Hey. Number 1, I would like to see J. Now get a linear. Actually, yeah, JKLM. JKLM. Okay. And then in number 2, I think the last 5. VW, XYZ. And then in number 3, the first 3. So, you should definitely get those finished before we start the next class. Okay, so get working on those now.